Assalamualaikum and good day, doctor. I am Nur Rajiana, and this is the scenario that I have created with ways of analyzing the organic and inorganic materials present in this scenario. The scenario is that a municipal water treatment plant reports that several neighborhoods near an industrial zone are receiving tap water with a metallic taste and yellowish tint. Public health authorities urgently need to determine whether heavy metals, especially lead, cadmium, and copper, exceed safe limits. Before deciding on atomic absorption spectroscopy, these are a few preliminary analyses that could be performed. The first is visual inspection and turbidity test. For example, water appears yellow and slightly cloudy, suggesting dissolved metal or particulates. Second is pH and conductivity measurement. Higher conductivity hints at dissolved ions. Third prefix analysis that could be done is colorimetric metal indicator test, which shows the presence of transition metals but cannot specify their concentrations. ICP-OES, which is inductively coupled plasma optical emission spectrometry screening, also can be done. However, it may be too expensive. Therefore, there is a need for element-specific, sensitive, and affordable method which relates to atomic absorption spectroscopy with similar properties. To confirm the presence of heavy metals in the contaminated water sample, a qualitative atomic absorption spectroscopy scan is performed across the wavelength range of 220 to 340 nanometer. Each heavy metals has a unique absorbance peak due to its atomic electronic transition. The graph displays distinct absorbance peaks at these exact wavelengths. These peaks confirm the presence of cadmium, lead, and copper. Cadmium is shown by the peak at 228.8 nanometer, lead at peak 283.3 nanometer, and copper at peak 324.8 nanometer. Thus, qualitative analysis verifies contamination by cadmium, lead, and copper. Quantitative analysis is done to quantify the concentration of metals in the water. The calibration graph was generated and each line on the graph shows a linear relationship following Beer's law. We're assuming the water sample gave the following absorbance readings, which are 0.54 for lead, 0.28 for cadmium, and 0.48 for copper. The quantitative results show that water in this scenario contains 3.0 ppm lead, 2.0 ppm cadmium, and 3.0 ppm copper. For advanced method, the prefix analysis forces the analyst to use UV-Vis because organics containing chromophores absorb strongly in the 200 to 400 nanometer range. UV-Vis is fast, inexpensive, and requires minimal sample preparation. It can also follow Beer-Lambert law to quantify pollutants. The graph reveals three main peaks, which are at 260 nanometer, showing the presence of aromatic group, 280 nanometer, showing presence of carbonyl group, and also 320 nanometer, showing the presence of conjugated group. These peaks confirm the presence of organics in the water sample. As a conclusion, the sample contains aromatic and conjugated organic pollutants. The calibration curve is produced by measuring absorbance at 260 nanometer, which is the strongest organic peak. Using standards from 0 to 10 mg per liter, a linear plot shown above is obtained. The equation from the plotted line is A equals to 0.095C plus 0.01. If the unknown sample shows an absorbance of 0.47 at 260 nanometer, the concentration is 4.84 mg per liter. Therefore, the water sample contains approximately 4.8 mg per liter of organic pollutants measured as aromatic chromophores. All the analytical results from UV-Vis spectrophotometry for organics and atomic absorption metal analysis for inorganics collectively confirm that the water sample contains both organic and inorganic contaminants. These are the brief conclusion for both inorganic and organic pollutants present. These are the references I took to make this analysis. Thank you.